Good afternoon, everyone, and welcome to a new session on our webinar series in the GloBIAS webinar series. I am Edwin Hernandez. I am going to chair today's session. So first, allow me a little bit to introduce to you what is GloBIAS and what we are doing this. GloBIAS, sorry, it's the Global Bioimage Analysis Society. It was established 2 years ago, supported by the Chan Zuckerberg Initiative Funds. Right now, we are more than 50 volunteers, one community manager, Krista, that is here with us, and 12 members of the steering committee. Right now, we are a registered association, a non-profit association since October of the last year. And our goals are to create a sustainable base and a legal entity for knowledge exchange between the members of the society, develop a curriculum for the biomass analysis, create and maintain repositories for training materials, consolidate the standards for biomass analysis, and part of this work is to regularly organize in-person and online events like this. For in this part, we create a seminar series to provide a dynamic platform for biomass analysis to enable to stay up to date in the latest developments in the field, and it's designed to cater intermediate and advanced analysis. We are focusing on practical and high-level content that extends beyond the basic instruction. We want to thank you to the Broad Institute for providing help with the infrastructure for this webinar series. And also, I want to inform to you that this seminar will be recorded, and questions might be later transferred to the image.sc forum. Okay. And now, please allow me to introduce today's speaker, Dr. Peter Bankhead. Dr. Bankhead is reader at the Center for Genomic and Experimental Medicine in the Institute of Genetics and Cancer at the University of Edinburgh. He's widely recognized in the field of bioimage analysis, particularly for his contribution to open source software development. He's the creator and lead developer of QuPath, a powerful and user-friendly software platform for digital pathology and whole slide image analysis. QuPath has become an essential tool in research and diagnostic environments, and in the image community worldwide adopted it. Dr. Bankhead's work lies in the intersection of computer science, pathology, and microscopy, with a strong focus on improving the accessibility and reproducibility of image analysis methods. His efforts to build intuitive, open, and transparent tools have significantly impacted how image data is analyzed and interpreted in the biomedical research. We are very pleased to have him today to share his insights. And please join me to welcome Dr. Peter Bankhead. Pete, the screen is yours.
Thank you. Thank you very much for that very nice introduction. And I hope I'm going to share the right screen at the moment. Yeah. So my computer has just decided to change what my main screen is, but hopefully this still works. Can you see my presentation? Okay, good. Yeah, very nice to be here. Thanks for the chance to speak to you about QuPath. So I was thinking a bit about this presentation, and I had a good idea or a bad idea last night. So what usually happens when I give a presentation is that I look through all the slides I've given before and I try and assemble some new presentation, then I decide I don't like it and I create new slides up until the last moment, and then it's all very rushed and my presentation goes by in like one long sentence, or at least it feels like that for me, over an hour. And I thought, well, let's try something different. So I'm going to try a live demo here. Only decided that last night though, so I haven't actually done the live demo yet, so we'll see how it goes. It's going to be a little bit dangerous, but we'll see how it works out. So the plan for today is I want to give you a brief introduction to QuPath, but not a lot of slides. I've only got a few slides here. If you are interested in seeing any longer presentations on QuPath, there are some on YouTube already, so you can check those out. Or perhaps I recognize some of the names of the people here, so you may already have heard them, so at least you're not going to get the same thing again. And then I want to give a live demo of the very latest version, which means like the in development version, with changes being made last night and this morning. So you can expect it's not necessarily going to go smoothly. I would be very surprised if I don't have to force quit and restart at some point. But I'm going to give this a go. So then at least you know that what you're seeing is going to be the very newest stuff. And then there's going to be questions and hopefully answers if you'd like to ask any, and I will try to answer them. So who's this for? So I never know exactly who I'm going to be speaking to, or I don't want to presume that they necessarily know QuPath. So I hope this webinar is going to be useful if you don't use QuPath at all, and you should get at least a feeling for the software and the kinds of things that it could do. But if you do use it, you should be able to see new features. I'll show you at least the way in which I use it, so you might see things that you haven't thought of or you haven't encountered before. At the same time, if you want to tell me things that I haven't thought of as well, that's always good, because people using the software often use it in ways that I don't think of. And especially we're going to talk about what's going to come in 0.6, because what I'm going to show you today is the basis of the upcoming version of 0.6. It's also for people who develop QuPath, including me, because yeah, speaking about it gets us that little bit closer to releasing 0.6, which we've wanted to do for a while. So the current stable release, if you go to our website, is 0.51. That's the one if you click the big download button, but you can see there's a banner at the top of the screen. We have a release candidate, well, the third release candidate for 0.6 available for testing, and hopefully we'll have the fourth very soon, depending upon how this goes today. So I'm not going to talk about 0.5, I'm going to talk about the new stuff. It was first announced for I2K in Milan last year. We were hoping to have it available then, because we have got some videos online from different people in the group, give tutorials on different parts that they were working on. And so these videos are available as well. But we haven't quite managed to finalize 0.6 because whenever we made the release candidates, we recognized some things that we needed to deal with before we wanted to make the final release. I said crucial with an asterisk because they weren't necessarily all crucial. I do admit that as we were making some changes with some new ideas, or I was using QuPath and it was annoying me in some ways, and so I started adding a couple of different features I thought would be really quick, and they slightly escalated, but you'll see some of those today. And lastly, it's very hard to make a new release because it's a bit scary, especially as more people use it. And so probably a couple of the new features that I added were just because I was a little bit nervous about making the release. The reason for that is QuPath has quite a lot of users at this point. It's at over 700,000 downloads, but that's across all versions. The last version alone has over 175,000 downloads apparently. So it's going to be some people downloading it multiple times, but I think it gives us some idea of the number of users that we've got. So it's always slightly scary to make a new release and think that, yeah, you're going to be potentially affecting the analysis of quite a lot of people. Close to 5,000 topics in image.sc is one of the main softwares discussed there, and well over 1,000 citations per year at the moment. So yeah, please do cite the paper because that helps with the kind of statistics of justifying our existence. But the fact that there's a lot of users really isn't the point of it. The sentence I always have in my head is that we don't want to maximize users, we want to maximize the usefulness. And so if it's very useful to a large number of people, that's fantastic. If it's very useful to a small number of people, that's also fine. We just want it to be as useful as possible. So we're not trying to sell QuPath as being the thing that you should definitely use. We don't want to replace other software, especially not other popular open source software. So if you like Python, Fiji, Elastic, all of these self-profiler, you should still use them. QuPath isn't trying to do the same as any other application, but it is trying to provide a unique approach, and so it helps to understand how it works, because you might find that sometimes that approach really fits and it can make your life a lot easier. And so for this presentation, I don't want you to convince you should use QuPath, but I want to give you the idea of what it can do, and you can decide for yourself whether or not it's going to be useful for you. So the most obvious difference between QuPath and other software or other popular open source software is that it was designed from the beginning to support whole slide and highly multiplexed images. Whenever I was writing it, basically I wrote it around 2015, 2016, because I couldn't work with whole slide images in existing open source tools. I spent a couple of years trying, didn't go very well, and then ended up sort of accidentally developing something that went on to become QuPath. And so initially we were looking at supporting whole slide images, so these very large multi-resolution pyramids where you could have a single image about 60 gigabytes in size, and my computer had about 4 or 8 gigabytes of RAM at the time, so you're always after working at the limit of that. And then because I'd worked previously in a core microscopy facility with lots of fluorescence images, I always wanted to kind of get back into fluorescence as opposed to these bright field pathology images only. And so we developed features in QuPath for highly multiplexed images. And so here is an example, and I've given the source below. So this is from an imaging mass cytometry image, but also works with fluorescence. But because QuPath is designed for these things, its approach makes some things easy and it makes some things hard. And that's why, yeah, really I wouldn't recommend that you use QuPath over everything else. I mean, I still use Python a lot. I use Fiji all of the time. Because different software makes different trade-offs. In QuPath, there's some things that you could do really easily in other software that you can't do in QuPath, or not easily at all. Like, you can't change the pixel value, you can't duplicate an image. Even thresholding is hard when you have a 60 gigabyte data and you need to figure out what resolution you want to threshold at. So some things that are really simple elsewhere are actually pretty awkward in QuPath. On the other hand, in QuPath, you can handle billions of pixels, you can handle millions of regions of interest and classify them, applying machine learning, and this becomes quite easy. And so depending on what you want to do, you might find that QuPath makes things much easier or harder, and so sometimes using it in combination with other things is the best way to go. So then, now is the point at which I'm going to try and give this live demo. Please be understanding if it goes wrong, and I do expect to force quit at some point, but let's hope that it works. And I also want to point out that I'm running this on a 13-inch MacBook Pro M1, and the point I want to make is that these are big and difficult images, but I don't have the newest of computers. I have a slightly newer one, but I decided, well, let's do it on the older one, because, yeah, that's the one I was working on today, and I figured it might give a more realistic view. So I want you to be reassured that if you want to work with these images in QuPath, you don't necessarily need the most up-to-date, impressive computer with loads of RAM. Okay, and because I'm not going to come back to the presentation, I'll just have my thanks slide here. So here I've listed the other people in the group, and so I'm going to be referring to some of the work that they've been doing throughout the presentation. And then, so that's Alan, Fiona, Leo, Laura, and Thibaut, and then some past members, including Melvin, who's worked with me for a couple of years. And so, yeah, just want to say thanks to these people, and also they are not to blame if this demo doesn't go as well as we hope that it might. Okay, you can see that I'm also running this from IntelliJ, so I'm running it from my IDE in the background, so this really is the very latest code. Okay, so here I have opened up QuPath, and I am trying to find my folder of sample images. Okay, so this is the QuPath user interface, and just to get started, I want to open some images, but the best way to do that in QuPath typically is you create yourself a project. So just an empty folder on the computer, call it whatever you like. And what we can do is we can go to create project and select the folder and so on. What I want to do in this demo is show you the way in which I use the software, which is sometimes, yeah, a little bit different. I use lots of the shortcuts and so on. Okay, yeah, I just realized I didn't reset my preferences, so maybe I should reset my preferences, which is also risky, but then it'll look more similar to what you see whenever you open up for the first time. Okay, so I created this folder. I will drag it on top, so instead of going to all the buttons in here to create a project, the easiest way is just drag an empty folder on. It asks, do you want to create a project? I'm going to say yes. And now I have a project. I don't yet have anything in it, but I have a folder of images here, which is unfortunately opening on my other screen. But you might be able to see that I have selected some images. I will drag them over on top of QuPath. It gets a list of the image paths. Some of these could be like bioformats, files read by file formats that contain multiple images. In this case, they all contain a single image. And then I'll just ignore all of the other options and say import and allow QuPath to bring in all of these. Okay. And so now I should be able to double click on image to open it. And QuPath will ask me if I want to set the type of an image. That's going to be important for some applications because it makes a difference if you're running cell detection on a fluorescence image versus a bright field image. It also makes a difference what kind of stains that you have in your image. And so QuPath needs to know the image type for certain operations. For others, it doesn't necessarily care. So in this case, it's H&E, so I'll just accept that. And then I have an H&E image opened up within QuPath. If I click on the image tab, there you can see that it is Brightfield H&E. We get some metadata about the image, like the pixel size and so on. And if I decided that I've set the wrong type, I can go in here and double click on it and I can make changes. I can also double click and change the pixel size and things if I needed to. So I want to give you a brief sort of overview then of QuPath user interface, but actually in the new version, we have a new extension which helps do this for us. Actually, I'm going to make a change because I assume you're not all Mac users. I'm going to turn off this system menu bar, and now it's going to look a little bit more like the Windows one where we've got the options down here, which might be a bit easier to see in the webinar. I am also going to click this button to show input display. And if I could find it, if it has appeared on the right screen, which it might not necessarily have done. Oops. Center off screen windows. No, I've messed about too much with my monitors, and so I can't show you that at the moment. Okay, so this was a new feature that I wanted to show. Help QuPath Tour. So this is basically going to give you kind of an overview of the user interface. You'll notice that it's actually doing it live, so it's able to show us what we actually currently have visible on screen at the time. And I can go through this and it will take me through each component and it will explain what it is and what it does. And so this is a new way that you can start to learn a bit about the software and what all of the different features do. And so one of our goals here is, so QuPath is extensible. You can write plugins and extensions and things like that for it. But what we try and do is we try and sort of make it more unified. It's not probably as easy to extend as something like Fiji or even like writing your own Python libraries and so on. QuPath tries to give you things in a very unified way. And then if it still isn't enough, you can add extensions to it. And so we tried to sort of standardize things quite a lot, and then that makes it easier to create these kind of tools that explain how you would expect it to look, because the customization is a little bit more limited. And so here it's taking us through this pane on the left, and it's explaining what all of the different tabs do. One of them, one of these buttons up here, which is quite interesting and also relatively new, is this help viewer. And so this is another way in which we are trying to have QuPath help you if you get stuck. Because as I showed, we've got almost 5,000 topics in the forum, and really appreciate people in the user community answering lots of questions in there. But whenever we see the same questions coming up again and again, we often think, oh, okay, maybe we should make the software a bit easier. And so we have the help viewer to try and point you in the direction of things that might be going wrong. And so if I click on this, and if I put my cursor over something, it can explain what the different options might potentially do. But there's certain buttons that I might press that might say hide things that could become important later. And here we get a little message in the corner. So you might notice that little symbols appear on top of this help button, and those symbols are indicating there's something in here that you might need to know, and if you press on it, then you can get a little bit of information about it. And so we might see that come in useful, and keep an eye on that. If you get stuck in QuPath, check this, because it's possible that it's already going to give you the answer to why you're stuck. Okay, so we have a viewer. I can use the scroll wheel in my mouse to zoom in and zoom out. I can click and drag to pan, move around. I can click up this image in the top corner to move around. What I can also do is I can type keys to do things like digitally separate the stains. So you remember that we have an H&E image, and I can actually apply color deconvolution to that to digitally separate the stains. It might seem a little bit mysterious, but what it's actually doing is it's using our kind of brightness and contrast tools, and the number that we press is basically activating a different one of these visualization channels that we have. And so these adapt according to the type of image that we have. So that's why QuPath always insists on asking you the type of image that you've got, because these things can change a little bit depending upon what you tell it. So it's not necessarily a big deal if you're just opening an image and doing certain operations that don't really matter, but sometimes QuPath really benefit from knowing the type of image that you have, and this is one of the places, so this brightness and contrast tool, that also give you these extra features. One of them is that you can change the gamma in the viewer. This is not changing the pixel values in any way, but it's allowing yeah, it's allowing you to adjust how the image appears. And what you might notice is we have our little orange circle up here that's telling us we've got a warning, and that's saying the gamma isn't 1 because changing the gamma is a slightly suspicious thing to do sometimes in image analysis. So we've got to reset it there, the warning's going to disappear. And so that's what I mean, that we have these kind of features in here that try and guide you towards the better use of the software, and that's something that we hope to expand upon over time. Okay, so we have our image. I'm going to be working with images which you may well have seen before, certainly if you looked at the QuPath documentation, because we've got links to them there so you can download and explore them. So apologies if you're sick of looking at these images, but hopefully you're going to see enough new features in here that not everything will be familiar to you already. So what we might want to do here is to measure, let's say, the size of the pieces of tissue. So I might click the rectangle tool, draw a rectangle. It's not a terribly good representation of the piece of tissue, a rectangle. I can go ellipse, also not great. More interesting would be a polygon tool. And the polygon tool works in two different ways. You can click individual points, or you can click and drag and it becomes like a freehand tool. And then just double click at the end. This button, if I double click elsewhere, then it's not selected. So selected is yellow. I can turn it on and off using this button to show and hide. So this is called an annotation in QuPath, and I can turn it on and off with this button, but I can also fill and unfill with the button beside. So let's suppose I want to annotate the next bit of tissue, and I want to do it with a different tool. So QuPath has a brush tool, which is also quite useful for annotating. But a nice feature about the brush tool is it's zoom dependent. So if you want to go details, you just zoom in. And if you want to go large regions, you just zoom out. But also, a nice thing about the brush tool is if we go a little bit too far, we can hold down the Alt key and then it becomes an eraser. And so if we need to remove details, we just zoom in. And if we want to get larger regions, we zoom out and we hold down the Alt key to deal with the fact that sometimes we might want to have an eraser. But for regions like this, where the tissue is really clear, actually it'd be much nicer if QuPath had a smarter tool. Unfortunately it does. So this is the Magic Wand tool, which is able to use the intensity information in the image, and that will help us to annotate more quickly in cases where we've got high contrast. And we can use the same techniques of zooming in and out according to the level of detail and hold down the Alt key to remove parts, and we can switch to the brush if we need to. So the shortcut is B for brush, W for wand. And so it tries to be intuitive in this kind of way, and so we can really adapt things as we need to annotate in the way that you want. And this also applies that, let's suppose we wanted to annotate at a nucleus level. Again, the wand, we would just zoom in a lot. We might switch between the wand and the brush in order to get the regions, and then we can annotate at a very small level as well. A trick for using QuPath often is that it does help. If you go a bit too far with your annotation, that's actually a good thing, because the Alt key allows you to push back your annotations from a distance, and actually sometimes annotating a bit too much and then using the subtraction mode is a really handy way to fix it. So once you've got this, let's suppose that we want to get measurements on those. We can click on the little table up here. I'll click Show Annotation Measurements, and then that should open our little table. We've got some radically different sizes of annotations, but we get little thumbnails for all of them. We get all of the measurements. And you probably haven't seen that some of this is new, but we're going to explore some of these other options later on in the demo. Okay. So that's the general idea of some of the stuff that you could do within QuPath. Basically in terms of visualization annotation. One other thing actually I want to mention whenever I'm here, another annotation trick which is quite handy, is let's suppose we're annotating things which are very close together. If you're using the brush and you hold down Control and Shift or Command and Shift on a Mac, then that can prevent it from overlapping existing annotations. So QuPath is a really useful tool if you're wanting to do like machine learning annotations or dense annotations, because you've got these many different annotation tricks to help you do that more effectively. Okay. All right. So let's switch to another image in a moment. Something that you might notice here is that we have multiple tabs in here, and it might be annoying that you can only see one at a time. So if you find that annoying, right click, undock the tab, and then we can have it separated out as other windows if you need to. So I'm going to switch now to a different image. Okay, turns out I had a breakpoint. Didn't crash there, but I had a breakpoint as I was debugging this last night. Okay, so we have a new image. QuPath has estimated correctly the image type. You can't necessarily count on QuPath to always get it right, but if you know that it's mostly going to be right most of the time, we can actually stop this annoying prompt turning up every time, and we'll just say always auto estimate. So whenever these dialogues pop up in QuPath, it is worth reading them, because if you find them annoying, there's often a way to make them stop annoying you. So that's what we can do in here. Okay, so in this case we have an image, and what I would like to do is to quantify the proportion of the tissue which is stained brown. If I click on here, you can see that the image itself is about 26, 27 gigabytes in size. But still on my not especially powerful computer, I can open it and work with it very easily, dynamically separate the stains very easily just by pressing these number keys, 2, 3, whatever I need, depending upon the stain that I want. And so, yeah, the fact that it's much bigger in the memory of my computer isn't an issue. But certainly, I don't want to be using the wand to annotate all of the brown in here, because that's going to take way too long. What I would rather do instead is use the polyline tool, give it a little example. I'm going to say that is positive, and I'm going to give it an example of what I think is negative. I'm going to say this is negative because it's kind of a bit more negative, or at least it's not the denser positive areas. And then I will go to classify, pixel classifier, train pixel classifier, live prediction. And now we have machine learning classifier trained across our 27 gigabyte image immediately. So that's able to work because it's not running at the full resolution. Still running at a pretty high resolution, so it's under 2 microns per pixel, but it's not the full resolution, and that means that the prediction is a lot lower resolution than the original image, and it's a lot less than 27 gigabytes. And actually, that would immediately give us measurements of the proportion that's classified as being positive and negative. So that's what we can see here in this bottom left corner. If I draw a region, it will automatically update as QuPath will figure out what pixels are inside and the percentage is positive or negative. It's not terribly useful in this case though. If I press C to turn the classification on and off, you can see that actually it's included as negative areas that aren't tissue at all. So what we want to be able to do is to draw a little region here, and I'll say I would like you to ignore that. It's gone a bit too far. Let's give it another region. I'm going to say this is negative. And maybe I want to clean it up a bit in here, and let's suppose I'm going to call this negative, depending upon what you want. Maybe you don't want to call it negative. And basically it's going to refine the pixel classification, always interactively train the new classification and applying it to the image. I can switch to different resolutions. So let's suppose that I think lower resolution is going to be enough. I can change it, and you can see how the percentages of positive and negative change depending upon what I do there. Actually, I need to make sure I don't have a region selected so that I get across the entire image. Sorry, my window was a bit too small. And if I increase the resolution, it will then start applying it at these different resolutions. And the prediction, the values will only appear whenever the selected region or the entire image, whenever the prediction is there for all of it. Okay, so it's giving me the area, and the percentage is positive and negative, ignoring all the space outside the tissue, which I told it to ignore. So whenever I drew these little lines, I gave them classifications for positive, negative, and ignore, and so everything that's ignored is not contributing to these positive and negative values. And so I could go for a very high resolution. This is where it's not very smart on my older computer, so that's definitely going to be a lot slower, and QuPath might have a bit of memory trouble as it increases too much. So if you're going for a high resolution, I would recommend you only do it on a small region. But for a moderate resolution, you can apply it across a whole slide image, and it should still be pretty fast. Okay, so having done that, let's go down to a low resolution, but still not very low resolution. And let's suppose that we don't just want to get the area measurements, but we actually want to be able to convert these into objects that we can do something with. So in QuPath, an object is kind of like a region of interest, but it also has extra stuff associated with it, like it has classifications and measurements and things. But you can think of it as like an ImageJ ROI, but an object in QuPath is actually a bit more than that. So let's say I select a region. If I save my classifier, then these buttons will come alive. My simple classifier. I just press save there. Otherwise, you can enable them. Normally, you have to save, and I'll show you in a second why that is. Well, I'll show you now. Basically, if you save it, whenever I start to apply things, it's able to store what I've done in there. So if I create objects then within this current selection, I'll just select the default options in here. It has then stored that command. So it's a little bit like ImageJ's macro runner. And to do that, it needed to know how I'd save the classifier. So we'll come back to that in a moment. But what I've done in here is I've generated then objects associated with the pixel classification results. So something that I would like to try, which may turn out to be a very bad idea, but let's give it a go. So this is, yeah, potentially the time whenever we're going to have to force quit this and give up. But let's go with creating objects across the entire image and see what happens. So remember, this is a very big, like 26, 27 gigabyte image and a not terribly good computer. So I'm really hoping that it's going to work. Okay. So that's a relief. If I'd done it at higher resolution, it might not have worked, but this is something that has been much better optimized within the last few weeks. So even within a few seconds on this computer, it was able to trace these objects. So I can create these really complex contours and QuPath is still usable. And so 0.5, it would not have been very usable if you've traced objects of that much. I'm going to slightly preview the fact that we're going to do scripting later because I'm curious as to know how many vertices we've got in here. Okay, so we have close to 500,000 vertices in that kind of multi-polygon representing all of this, and QuPath is still usable. So it could generate that within a matter of seconds and still is usable. So that's a big improvement over the previous version of the software. But what you can also then do is that if you have regions like this, you might say that you want to start editing them or do something a little bit more with them. This is where I have to admit that I tend to forget where all of the options are in QuPath sometimes. Okay, I'll right click and I'll say that I want to split this object. Having done that, then I've got the individual pieces of that annotation in QuPath. And so I could potentially delete any false positives or something if they're causing any trouble. What I can also do is that you might see here we have little locks associated with them. So those are to stop me accidentally dragging them into the wrong place or editing them. But if I right click and if I unlock that object, then I can start to edit it like with the brush tool before. It's just an annotation like the ones that we manually drew. So the pixel classifier allows us to create these kind of objects. And so, yeah. This is another kind of way in which you can use QuPath. So initially I showed that you could do lots of manual annotations, lots of tricks for that. Here's when you start to use some of the machine learning tricks and then some of the object manipulation tricks like splitting objects or merging objects and so on. Okay. What you could also do if I load the pixel classifier again, this is something that we probably want to improve sometime later. We can save the prediction image. So if you were to want to work on it somewhere else, And you can save it as an OME TIFF, but new in 0.6, you can save it as an OME ZAR. So that's like, thanks to a lot of work that Leo done and a lot of work that Alan had done in making the ZAR file format available through QuPath. And this would allow you to then potentially save your predictions from QuPath and make them available in Python or VT or somewhere else using either of these file formats. OME TIFF is perhaps more portable against more software at the moment, but OME ZAR is so much faster to write, and so that's probably the one we're going to come to rely on more in the future. And QuPath can read OME ZAR as well. Okay. Right. So I rearranged my order of things there and I lost some of them. Okay. So next example, I'm going to try and go through it a bit quickly so I've got time to show you some things which are entirely new within QuPath. I'm also going to use some of the shortcuts again. So this is Control and L or Command and L. It's the same shortcut as ImageJ often uses. And what I want to show you here is some cell detection within QuPath. And this is all described in the documentation, so I don't need to show it to you in much detail, because if you're familiar with QuPath, you've probably seen this example before. Important thing to know is that we have these kind of tooltip text for most things in QuPath. So if there's parameters you don't know what they mean, just hover your mouse over it or click our little help, and then the little help button will be able to make that text more instantly available to you. Okay, so here I ran cell detection. So this is a K67 example. What we want to do is to get the percentage of tumor cells which are positive. QuPath, with that one command, is able to detect the cells and classify them as positive and negative based upon the brown staining, so brown being positive. We immediately get our measurement then, so we've got the percentage of cells which are positive. So that would seem like our job might be done, except it isn't, because we actually want the percentage of tumor cells that are positive, not the percentage of all the cells. And so I'm not a pathologist, not necessarily reliable here, but I want to venture to say that these are probably tumor cells, these are probably not tumor cells, particularly around here. And so we'd like to be able to make the distinction between them. Fortunately, QuPath cell detection, in addition, detecting and classifying cells as positive or negative, and basically detecting the nucleus and then expanding that out, it has given us about 44 different measurements. So that's what we can see in here. We can, if we want, visualize these as measurement maps. We can adjust the contrast. We can also say to QuPath that actually we don't want to see the entire cell, we just want to see the nuclei, or actually we just want to see the cell boundaries. So this is by right-clicking we can adjust this. Or we can tell QuPath we want to add additional information. So we want each cell to know a little bit about its neighbours. And so that's what I've done in here with these so-called smooth features. It's basically calculated a weighted average. So if I was to look at the nucleus area, hopefully you can see this is a color-coded heat map of nucleus area, and this is what it's like after the smoothing, where we basically each cell now is the weighted average of its own area and that of its neighbours. The reason for doing that is, let's suppose we want to draw with our little brush again a few regions. Again, I'm using shortcuts. I'm using Shift and right click to bring up this little menu, and that allows me to quickly assign a classification to the regions. And then I'm going to say that I want to train an object classifier. So all of this is in the documentation. So if you haven't seen it before, don't worry that, you don't have to follow along too closely. I just want you to get an impression of what the software can do, is that it can then use all of these features to train a random forest classifier, apply it to the image, and then now we have the percentage of tumor cells which are positive generated automatically based upon these classifications. So red for positive tumor, blue for negative tumor. If I put the mouse over it in the bottom right hand corner, you can see the classification for each individual cell, so you can just make sure that you know how things have been classified. I can give it additional annotations if needed, and I can refine the object classifier if I want to, but basically that shows you how quickly you're able to generate, for example, an object-based classification to go along with the pixel classifier that I showed you a moment ago. Another thing that may or may not be useful for this specific example is the idea of creating a density map, and that would allow us to find areas of high density. So this is for all, well, it says detections here, but it's basically cells. They're the same thing from QuPath's perspective at this point. Cells are the ones that have the nucleus as well. So we can just say this is a density of cells, but we can also have a density of tumor cells. We can have a density of specifically like positive tumor cells. And so we can define densities in different ways, and then we can find these hotspots and so on if you want to do that kind of thing. Okay, so that is an example then of the kind of work that we can do in QuPath with objects. Okay, I want to switch then very quickly to here's another image, bright field H&E. And I want to find an example where QuPath cell detection isn't great. So I will select a region in here. I run cell detection. And okay, so the colors aren't fantastic, but hopefully you can see that QuPath has done some kind of cell detection. It's a really tricky image though, and it's maybe not fantastic. Actually, if you don't like the colors, we can go to the preferences and we can change the default object color. So there's lots of different colors that you can change in here. So the default object color, let's make it slightly different. Okay. So previously I said that you can add extensions to QuPath. One of them was the Stardust extension. So we didn't not at all write Stardust. So we just benefited from the use of Stardust. We wrote the Stardust extension. So the authors of Stardust don't have responsibility for this extension. So if you're not happy with the extension, it's not their fault. But the Stardust method was developed by others, by whose names I cannot quite pronounce or remember at this exact moment. Martin Weigert, Uwe surname I've forgotten. Yeah, so you can check out their work and give them the credit for the use of Stardust. The extension in QuPath works using a script. So I've dragged an example script on here. If I run it, hopefully what we will see shortly is, okay, so these are the Stardust cell detections in QuPath. So I'll fill them in so you can see them more easily. And so the idea here is that QuPath basically gives you the framework. It gives you some out-of-the-box methods like for cell detection and so on. But then you can potentially replace individual parts with other algorithms. So if you don't like QuPath cell detection, you can potentially include Stardust instead and then use that. But because then QuPath will give you the features associated with the cells, you can then still work it into these complete workflows with machine learning and so on. But the method that we have developed more recently, or specifically Thibaut in my group has developed more recently, is called InstanceEgg. Yeah, let's always check online. So this is an alternative method for cell detection. And this is where I probably regret resetting my preferences earlier. And it has a user interface, so you don't need to just run it through the script. But if I run this using InstanceEgg, again, we get a different cell detection results, but we can get the measurements associated with it. We also have a nice little feature in here that we can assign random colors to all of our cells if we want to be able to distinguish them more easily. And because this is available as a QuPath user extension, this might become a kind of a more popular way to do cell detection than QuPath's built-in one, because this is a PyTorch-based deep learning method developed by Thibaut. And he's got a presentation online where he describes it, and so he's the one to ask about all of the methods, but we will see it again in a moment. Okay, there was another example that I wanted to give you, but in the interest of time, I guess I will just switch over here and then show the InstanceEgg isn't limited to just bright field images, for example, nor is QuPath cell detection. So here, I have a fluorescence multiplexed image with about 7 different channels. If I run QuPath cell detection in here, it can detect the cells, but all it's doing is detecting the nuclei and then expanding them out indiscriminately. But if I run InstanceEgg, Thibaut's method instead, we have a model for fluorescence. And one of the nice features about it is that it can take any number of input channels that we want to give it. And so here I'm giving it all 8 input channels, and then it's able to make a much smarter kind of estimate of the cell boundaries based upon the information across all of the channels. And so his presentation talks about this in a lot more detail. But yeah, so this is kind of the InstanceEgg cell segmentation results applied to multiplexed images, and so they could be a lot more convincing than QuPath cell segmentation. So I'd recommend that you check that out if you're working with these kind of multiplexed images. Whenever you do this in QuPath, you get, again, a list of measurements associated with the different cell compartments and the different channels of the images, so then you can work these into machine learning workflows if you want. And then start to then try and classify the cells, for example, if that's what you would like to do. But let's suppose in this case that I was going to give InstanceEgg just one marker and nothing else, then what you should see is that lots of these cells are going to disappear. Yeah, because it hasn't had all of the information. So that's just a brief little proof that it really is using the information from the different channels for detection, and not just for detection of the cells, the nuclei, but also the cell boundaries. And actually you can specify, you can detect just one or the other, you don't, or both at the same time. And so it's a really flexible, really powerful method, and it's also pretty fast. It's much faster than any other similar methods that we know about, with this incredibly useful feature of being able to handle any arbitrary combination of input channels. So yeah, definitely recommend checking out that method. Okay, I don't think I'm going to have time to show you everything that I would like to. I will just then incredibly briefly show you one brand new thing from a day or two ago. So if you happen to be, so QuPath is mostly for 2D images. If you have large 2D images, that's fine. If you have 3D images, it can hopefully open them and then give you sliders. The way in which you interact with them has changed a little bit in the latest versions of QuPath. And so we have different ways of moving between the different Z slices. So you can use the arrow keys to go up and down and left and right to change time points in Z. But we also have these nicer controls that allow you to switch between them. But something else that we have added just incredibly recently is a show Z projection overlay. So we can view an overlay of a max projection. So you see that if I change the Z slice, it doesn't matter anymore, because I can switch between different overlays within QuPath depending upon what I might want to see. And this also interacts with the channels that we have displayed. So the overlay will update depending upon what we do in there. And so it's all kind of unified. So that's without the overlay. I can turn channels on or off, and then that's with the overlay. And so that gives us, for the first time in QuPath, easy access to things like maximum intensity projections or mean or median. I don't recommend that you apply them to enormous Z stacks because it will still have to read every slice of the image in order to be able to generate them. But it is potentially quite a useful feature to be able to work with this kind of stuff. Something else that I'm not really going to have time to talk about, but one of the big things that was slightly delaying 0.6 is that we realized that we now have got so many interesting and useful extensions like InstanceEgg and like one for connecting with Python, which I won't be able to talk about today, that we really needed a way to manage them. And so we've created this extension manager. Well, mostly Leo has created this extension manager. And so this is now should make it much better to be able to work with different extensions. And you can see that we have an update available for the Amaro extension. So this is a massive rewrite of our original extension for linking QuPath with Amaro, and then Leo has really led this, and it's turned into an enormous amount of work. And so in addition to the extension manager, he's created this Amaro extension, and if I would then click on it, I can choose which version of it I want, and I can get the optional dependencies. And one of the big advantages of the Amaro extension is that it's able to get the raw pixel values, whereas our previous one could only get like JPEG compressed tiles, was limited in the images that it could support. So our extension manager should make it much easier to work with this, and the Amaro extension is potentially really useful if you work with that. We had some fantastic help and feedback from people in the EPFL based upon their experience with Amaro and QuPath. Other things that I won't really have a chance to talk to you about because I should really stop in case there are questions. We have, for example, an ImageJ script runner. A problem that we had before is that we had an ImageJ macro runner, wasn't terribly good. If you wanted to use an ImageJ script or do something like an auto threshold, it wasn't super easy to do. Now we have this ImageJ script runner, and so that will allow us to run yeah, different commands within this. If I could remember exactly, return the Roy. Yeah, if I could remember how it works, it would give, but that gives us access to stuff like ImageJ's auto thresholding methods and so on through this. And so this will be in the new version and it should be documented. Because ImageJ doesn't handle the whole slide image itself, we have to sort of crop it up and resize it. And we have to figure out how we're going to pull back the results from ImageJ into QuPath. And that's what all of these options are about. But essentially this allows us to do lots more things. Like, so I applied the triangle threshold. Let's suppose that I want to switch to Otsu. We can then start to run ImageJ macros in a much more flexible and interesting way within QuPath, so that you don't necessarily have to be familiar with all of QuPath scripting. If you have ImageJ macro skills, you can start to use them as well. Okay, I guess I should probably stop there. I think there's lots more things that I would like to be able to tell you about this. I guess we'll have to put them in the documentation, but these are some of the new features within QuPath, including some of the existing features and some slight changes to them. Oh, sorry, one more just before I stop. If I go over here, detection measurements, a little thing that we have in here that might be useful if this will open. Or is this the time when it crashes and really shows me that I shouldn't have stopped, or should have stopped? We have scatter plots now as well. So this won't necessarily give you all of your measurements, but we are able to get, like, it might be limited to say like 10,000 points because we haven't been able to scale up to like millions of cells yet. But then this is like an interactive scatter plot that would allow us to link between cells and measurements. And so that's a new feature as well. We can look at scatter plots across multiple measurements and so on. Okay, I think I should stop now. If there's any questions, just let me know.
So yeah, we have in fact a lot of questions. Thanks again for this amazing advance about what's coming with QuPath. And so let's, Isabel and Esteban, ask you some questions, but also remember that all these questions will be answered also in a future image.sc forum question. Esteban, you want?
Yeah, I'll start. There's a lot of questions, so we'll probably not going to get through all of those live, but I will start by Emmanuel asked about how's the current process for integrating deep learning and machine learning models into QuPath, particularly how about importing custom models trained outside QuPath and using it within the QuPath GUI, that is for classification, segmentation, or image translation.
It's definitely something that we want to do. It's something that we've kind of been working on. Lots of things that exist in QuPath are actually kind of working towards that goal, even if it's not necessarily obvious that they are. It's a really tricky problem because our images are so big and because most existing models in the bioimage analysis field aren't really designed for pathology, because you've got the awkwardness of how you resolve tiles, but also if you end up with like a prediction for every pixel, but that is like 40 gigabytes in size, you need to somehow turn that into a meaningful result, like tracing contours. And then, yeah, so it's not an easy problem to solve in a general way. And so we have lots of things in there that are designed to try and help with it. One of them being the OMEs support, because that might be something that we use. InstanceSeg is kind of our example of one specific place that we have integrated because Thibaut and our group had worked on it. But certainly we are trying to generalize it for others. We can currently kind of prototype stuff if we spend a lot of time hacking it together, but that doesn't generalize well. And so rather than release that and then not be able to finish it because we spend all our time on image.se answering people's questions about it, we're trying to get it sort of more finished and working before we announce it, but it's definitely something we want to do.
Okay, thank you very much. Wonderful talk, Peter. We have several questions about InstaSeg, how it works, and from Ofra Golani and from Darren Thompson. And they want to know how to train, how many channels can it support, and several more other questions about InstaSeg.
So I don't think Thibaut is here. He is really the one to answer that. So it's all open source. So he has his Python repository of his original code and all of the training, and he's got 2 preprints on it. And he's got instructions there for how you can train models of your own. And then we have the QuPath Instance Egg extension, which is only really for inference at the moment. And so it's not for training directly within QuPath. We also have this project that Alan talked about in Milan called QuBaLab, which is our link to Python. And so there are kind of ways that they might come together a bit in the future. But Thibaut's probably the real one to speak to you about detailed instance egg questions. And he's active on GitHub and he's active on image.sc, and I can point you in his direction.
One more, Sonia asked if it is possible to adjust the range of the scale for visualizing histograms for each stain individually. Yeah.
So would that be, I guess, in the brightness and contrast dialog, perhaps?
So some more clarification is, she's been optimizing staining to convince people, she usually adjusts the histogram equally for each image, same scale. Yeah, maybe if Sonia, if you are there, you can post in the chat or in the QI if you refer to brightness contrast.
Yeah. I've only just seen where the questions are now.
Yeah. Yes, contrast window. Thank you, Sonia.
Yeah, so not really. You can't do an awful lot with the histograms there, and part of that is that it's an awkward problem because the images can be so big that the brightness and contrast doesn't necessarily reflect all of the pixels in the image, because we can't necessarily access all of the pixels in the image, or it might take a really long time to decompress it all and build a histogram for everything. And so actually what you see in the brightness and contrast is really just kind of a summary histogram, usually calculated at a low resolution. In the latest version, if you have a Z stack, it will even just kind of update as you browse more of the stack based upon what pixels are available to it, because we have problems that if we try and generate a histogram of everything, we can't really do it. And so we don't make it super customizable because it's not really, it's really just to give you an impression. And so I'm afraid you can't really adjust it very much at the moment.
Okay, so I think we don't have time for more questions, but for sure we are going to try to answer all the questions that we have in the forum and to expand this discussion because it's going great. So also allow me to share with you that we are going to have an upcoming seminar in the 24th of April with the Dr. Betsmini, that she is going to talk us about self-profiler lessons from the last 20 years and plans for a few more than that. And it's going to be 24 at 6 p.m. Central European Summertime, because we are going to change the hour this weekend. So thank you all for attending in this amazing seminar. Thank you to Pete for this wonderful talk, this wonderful points about what is coming in QuPath. We are excited to use soon and hope to see you in the next seminar. Okay.
Thank you.
Thank you all.
Thanks, everyone. Have a great day.
Thank you.